Right here in front of me should be my new Antigravity A1 drone. However, unfortunately, due to the complete incompetence of Parcel Force, who can't even do the one task that they're meant to do, which is deliver, mine hasn't arrived. However, that doesn't stop us understanding what's going on inside, because today I'm going to be sharing with you not only some teardown images from inside the Antigravity A1, but also talking around some of the FCC reports and our findings about what exactly is going on under the hood. And buckle up, we have learned so much about this drone already. We know pretty much everything we need to know. So let's get on with it and let's take a look at what's really going on below the hood. Okay, so we are going to start with the A1 teardown images from the FCC filings. Now here you can see the top, we have it removed. You can see our GPS module and you can see our ESC. Scrolling down a bit further, we can then from the bottom see that there appears to be a main board with a large cooling fan and heatsink, and then on the bottom of the chassis you can see some additional boards. So what you've got here is your vision processors as well as your servo motor for those little legs. Going on a bit further, they start to pull things off. So you can see there the main board with the heatsink removed. And what you're starting to see here is the layout of this drone internally is on the top. You've got a GPS board, you've got your ESC board, and then on the bottom you've got the main system processor board with another board on the bottom for the vision processing cameras. And then you've got your little motor at the front. Going a bit further, you can see they've got another picture with the removed from the shell. You can see the antenna cables there, but it really does appear to be quite a nice, simple layout. Board on the bottom for the main vision, the control of the drone, pretty much the main system side of things. And then you've got your GPS and your ESC on the top, which you can see they've removed there. Going down a bit further, looking at the ESC board in a bit more detail, not a lot really to say here. It looks very much exactly what you would expect to find in a consumer drone from the likes of DJI. You can see on this side of the board, you've got some ESC controllers, you've got your motor drivers, and then you've got your main controllers there. By spin, typical what you find in DJI, exactly the same type of components. And then you've got your FETs located down there. Moving down to the GPS, what's great to see here is the Antigravity does appear to have a full GPS module, and it appears to be U-blocks as well, which is nice to see. So if we go down on the top, you can see there's a full-size GPS antenna, traditional ceramic antenna. So what this means is it should give some really good GPS signal performance. And then looking on the bottom, you've got the chipset hiding under that can. And just going in a bit further, it's labelled M10 or M150, so it's an M10 GPS module from U-blocks. Really good to see that they've gone with what appears to be a U-blocks module rather than some of the other Chinese ones that you do see on the market, because they do generally perform much better. Then we have the main board, and this is where things get incredibly interesting. You can see they've removed some of the compound and they do remove the top. And on the top side of the board, we're starting to get a better understanding of what is going on. Here we've got some pretty big chipsets. We've got the Umbrella CV5. We've got something here called a Sunrise 5. And we've got a couple of other chips as well. Now, I've spent some time looking at this, trying to understand what's going on. And it's fairly what I would expect to find in any DJI drone. In many ways, this is almost a mirror of what you would find in some of DJI's models, although the layout is a little bit different and we don't fully understand exactly what Antigravity is doing here in the sense of where they are running things. But if we go in closer, so if I scroll down, the first thing we'll take a look at is the Umbrella CV5. This is going to be the main processing chipset for the camera. I would expect this to be handling your main DVR recording. This is basically the same chipset that they use in the likes of the X5 cameras. Umbrella have been around a very long time. And Antigravity, or I should say Insta360, have been using Umbrella chipsets in their cameras for a long time. This chipset was designed to offer processing capability of recording 8K or 4K video streams. So this is going to be handling the main 360 video, the stitch in the recording, just like it does in the X5 cameras. Next to this, then, you've got a Kingston storage. It's an eMMC, and it's 4 gigabytes as far as I can tell. So that's 4 gigabytes of eMMC storage, which will be held in, most likely, the Linux OS, which runs on this chipset here. Next, we have the D-Robotics Sunrise 5. Now, this is a new chipset. I've not heard of this, but having had a dig around, and from what I understand, this is a CPU based on 8 A55 1.5 gig ARM cores. It has a big GPU on board, and basically this is a big vision processor. It appears to be designed for things like tracking, sensing. You can see here they're showing you human detection. They're showing here motion around buildings, detecting, track detection, deep learning, following a car. This is what's going to be handling all the vision processing on the drone. So the object avoidance, tracking. What isn't clear though is if this is also running the main flight OS as well. With 8 A55 cores, I think it's a very real possibility that this chipset is going to be running the main OS and flight control for the drone, and then the umbrella is handling the video recording. However, that isn't confirmed. It is just as possible that flight control is also being ran on the umbrella, but I think based on what this thing looks like, it seems quite beefy is the term I'll use. Next to this, we've then got some LPDDR4X, which is some memory. That is basically for this main chipset here. There is also something else up here, which also looks like a flash chip as well. Not clear what that is from the images, but based on the pinout, it almost looks like an SPI flash, if I'm honest, but it isn't 100% clear. And then going down to the rest of the board, you can see up this side here, there is some metal plates. These are in place for cooling for the RF side of things. The RF is on the other side of the board, but they're doing some heat transfer through the PCB. You then got your SD card slot, and then you've got some power regulation up here. Before flipping over to the other side of the board, do note that we have our antenna ports on this side as well. So 1, 2, 3, 4. Yes, this drone has 4 antennas for the main RF link, but we'll come on to that a little bit more in a minute. Next, moving to the bottom of the board, and this is where things get very interesting from my personal perspective, because here we have the RF side of things. Going in a bit closer to look around, first of all, we have a couple of chips from Micron. So this will be memory. So DDR, most likely for the main umbrella processor. You didn't see it on the other side. Because when we look on this board, there's no RAM next to this. This CXMT RAM chip is right next to the Sunrise. My bet is that is for that. And this is directly on the other side of the board to the umbrella. So I suspect that is the main RAM chips for the umbrella. We've then got a Fortress storage. So this is 32 gigs. And then we've got this other processor down here, which is quite an interesting one. And I've not seen this in anything before. But this is what they basically call a crossover processor. So this chip is from NXP Semiconductor. It's the IMX RT1064 crossover processor. And this is quite an interesting chip because it sits somewhere between an STM32H7 and a bigger ARM-based processor where you'd have to have external storage, external RAM. If you think about an STM32 series, it has onboard flash and onboard RAM. This is the same. So this processor has 4 megabytes of flash. That's more than you would usually get in an STM32. Usually get 2 megabytes. It's got 1 megabyte of on-chip RAM and 512 kilobytes of SRAM. So it's quicker, it runs at 800 megahertz, so it's more powerful than an STM32H7, but it certainly isn't remotely as powerful as some of those other dedicated larger ARM core chips, like that Sunrise chip I was talking about just now. As for what is this doing, I'm not sure. This actually could be running the flight control. It isn't clear to me from the layout of all of this where flight control is. As I mentioned earlier, it is possible that they're running flight control on the Umbrella. It is possible that they're running flight control on the Sunrise. But as this is a dedicated STM32 based chip, I somewhat wonder if this is handling flight control entirely on its own, and then they are running your vision on the Sunrise, your camera recording on the Umbrella. It would really, though, depend on what flight control software they're using, because we don't know. Is it entirely in-house? Is it maybe something like PX4 that they're having to run on a different chip? As an example, if they were using PX4 as a base, I could absolutely see it being used on a chipset like this, but it really isn't clear. All I do know is it's an ARM-based processor. Think of it a bit like an STM32H7 is the simplest term, but what exactly it is doing isn't clear right now. Going in next to this then, we've got some additional power regulation over here, and then the big one and the real interesting one is here, the RF front end, because here we have what we expected to find inside. You've got the main RF chipset, 4 power amplifiers, and just by looking at that image, we can tell you already that that is an Artisan AR803X series of chipset. This is a very similar chipset to used in the likes of the Potensic Atom 2 and the new Ascent system from Cadex. Now, what I can tell you is it isn't identical to the chipset in those models. It is the same pinout, but the markings are slightly different. The chipset in the Potensic Atom 2 and the Cadex Ascent system is labeled V2. This is labeled V3. Now, when you look on Artisan's website, it doesn't tell you that much about it, but what I do know so far is that there appears to be different variants of the chipset. It is the AR803X, but that X stands for whatever version they're going to ship. So there might be an AR8030, AR8031, 32, 33. There are different configurations of this chipset from looking at a lot of info online. It isn't completely clear what the differences are. I do know you can get it with RISC-V on board, or you can get it with an ARM core. And Artisan likely have different variants depending on the application the drone needs. And you can see here in this scenario, this is the first time I have seen this chipset used with 4 antenna lanes. The real interesting thing about the Artisan 803X is the fact that it is the RF baseband and MUX all in one. For anyone who follows this channel, you'll know I've talked about this before with previous chipsets from Artisan and the likes of DJI O4. DJI have their RF baseband chipset on DJI, which is now the S2. They then have to use a separate MUX. Then they have their RF power amplifiers. The earlier Artisan chipset that used the 9201 series, again, had the baseband on board, and then you had to use a separate RF MUX. Your MUX is what is generating the waveform on the desired frequency and handling all of the antenna I/O. Whereas with this chipset, it has the MUX and the baseband built into one. The big difference with the AR803 series is that it is a fixed function RF chip rather than a SDR like the DJI use on their systems or earlier Artisan systems, which we could class as an SDR. This, though, is more of a fixed function IC, but it is definitely doing a lot more in this drone. And when we take a look at the RF specifications in the FCC report in a minute, you will see that it's doing a lot more than we've seen it do in Ascent, because not only is this chipset running 4 antenna lanes, it's also capable of up to 40 megahertz bandwidth as well, compared to the 20 megahertz bandwidth that we have seen so far on Ascent. Now, if we jump into the RF FCC report, this actually tells us quite a bit more information. So, for instance, the RF power as well as the bandwidths available. If we scroll down, it supports 3 frequency ranges on the RF side of things. You've got 2.4 gigs for video, 5.2 gigs for video, and 5.8 gigs. Now, 5.2 gigs is only available in select regions, but it does support the 3 bands like we have seen recently introduced on other DJI models. Bandwidth-wise, the system supports 5, 10, 20 and 40 megahertz bandwidth modes in 2.4 gig, 5.2 and 5.8. And as I've shown already, it does have 4 antenna lanes, of which 2 can transmit and 2 can receive. When you do look at the image, all 4 antenna ports do have full RF power amplifiers. And what that means is, whilst you can only transmit and receive on 2 and 2 at a time, it can decide which 2 to use. All of the ports appear to be fully capable, so it isn't that there are 2 ports that can only transmit and 2 that can only receive. It does seem to have the full capability between all 4 ports. It's just limited to 2 transmit and 2 receive at a time. Also in the report, it does go on to tell us about the RF power. This drone can output up to 1 watt, and that has been tested. And there is also another little interesting tidbit in here as well, where they talk about there are actually going to be 2 versions of the RF in this board, or what they call FEM modules, front-end modules. There is the first and an alternative module, and this is actually seen in the teardown images. They actually have 2 different main boards. They appear almost identical, apart from they're using different power amplifiers on them. So it seems that either at the point of them designing this drone, they weren't quite sure which option they were going to go with, or simply due to production, they're choosing between 2 different sets of amplifiers, and that's why they've had to certify 2 different sets. Continuing on this board, this then jumps over to the Wi-Fi and Bluetooth chipset. This is the SPRD UWE5622. This is pretty much a cheap Chinese Wi-Fi chipset, which has been around for some time, and that is handling the main Wi-Fi communications. Moving on to the rest of the internals of the drone, you can see they show the bottom of it here. We've got the main vision processors as well as the little motor there for the legs. We just scroll down. There's not a great deal to show you here. Here's the back end of the vision board. Not really much processing on this. It's just going to be all outputted to that main Sunrise SoC. You can see there the vision sensors. Now they've removed the top. You can see them there and a chipset for that. But again, nothing particularly interesting or different than you would see on anything else. The only thing I did observe is they clearly broke it in the teardown because they bent that connector quite badly. Now, as I mentioned earlier, there are actually 2 variants of the internal board in this drone, and this has both of them, and the only differences I can really see between them is the RF power amplifiers. If I scroll down, the layout is identical. It's just they're using different RF chipsets, and there's a slight difference here for the cooling as well, but it's the RF side that has changed. So again, if I go down and get into the closer detail, here we go. You can see it is the same RF chipset from Artisan, but they're using different power amplifiers. So these are not the same power amplifiers. So if we just zoom in a bit more and look at the codes on these, you can see these look to be Skyworks, if I'm honest. Looking at them, that looks like Skyworks numbers. And then if we scroll up to the other one, let me just get up to the other. There you go. You can see the numbers on these. In fact, that looks like Skyworks as well a little bit. They're clearly different, is what I will say. So, and they do mention this in the RF report as well. And all they say is that there are 2 different modules and they have tested both of them. It isn't clear if this means that there's going to be different modules going to different countries. They've got the same RF power. There literally is no difference in the spec that I can see. I even dived into the report and tried to have a look at if one of the modules setups does 2.4 and only 5.8, and one of them does 2.4, 5.2 and 5.8. But no, they all do all frequencies. The only difference I can physically find is the chipset itself. From a specification perspective, it looks absolutely identical. Now, I have spent a bit of time digging through the rest of the FCC reports on the drone, the goggles and the remote, and I'll come on to the goggles and the remote in a minute. From the drone side of things, there really isn't anything else particularly interesting. Really, what you've got is as follows. So you've got the main board. This is the interesting board. So you've got the main board, you've got your GPS board and your ESC board, and then your vision cameras on the bottom. Your GPS is U-blocks based, full-size antenna, ESC, pretty normal. On your main board, you've then got your umbrella, CV5, most likely main camera SoC. You've then got 4GB of NAND for that. You've got your vision processor, your LPDDR4X for that. And then flipping over to the other side of the board, we've got 32GB of NAND, we've got some DDR from Micron, we've got this crossover processor, which will be handling some function, not exactly sure what they'll be running on that. And then you've got your Artisan chipset, your AR803X series, handling your RF front end for the main wireless link. Having gone through these images, I have to say, from the drone perspective, I am incredibly impressed with what I've seen here. This could easily be a DJI drone. Yes, there are differences. Obviously, it doesn't have OcuSync. This wireless link is not going to offer the same performance as OcuSync, but it is the best alternative on the market. It is the only alternative they could have reasonably gone with, because no one has anything close to what DJI have with the OcuSync chipset. But from the design of the drone perspective, I can say from what I've seen here already, this is leagues ahead of others like the Potentic Atom 2 and those cheaper drones. This, from a capability perspective, looks right up there from what I would have expected from DJI. And I'm really pleased that, looking at the hardware, this really does look like a true competitor to what DJI is doing. There is no reason they can't take off those 360 cameras off the front of this drone, put a standard camera on the front and deliver the likes of a Mini 5 Pro competitor. I wouldn't be shocked if we saw that in a short period of time. There's no limitations here around what they can do, and Insta360 Antigravity really do appear to have done a very nice job. Next, moving on to the goggles and the remote. And unfortunately, I don't have teardown images, but we do have the FCC reports. What this means is I'm going to have to tear mine down when they come, but that doesn't mean we don't know anything, because there's an awful lot of interesting info in here as well. Now, starting with the goggles. The Antigravity goggles support the SDR modes as well as Wi-Fi and Bluetooth. The SDR modes on this are 5 megahertz bandwidth. So that is the uplink bandwidth to the drone. Remember, the drone is transmitting video down to the goggles in either 5, 10, 20 or 40 megahertz bandwidth, and Antigravity is stating up to 30 megabits a second. However, the goggles will transmit telemetry data back up, and there is also something interesting about that as well. That telemetry data, though, is going up on a 5 megahertz carrier as well. What is very interesting on the goggles is also the fact that it has 6 antennas, not 4. So just like the DJI Goggles 3, there are 6 antennas in the goggles, of which 2 can transmit and 2 can receive. So it's choosing 4 of the 6 antennas to use at any time. I am really looking forward to seeing, does this mean that Artisan chipset can support 6 antenna lanes, or are they doing some after the fact switching? We'll have to look at that in the teardown in the future. Now, with regards to the RF power on the goggles, they do support up to 1 watt of RF power in telemetry back up. In the testing, we can see, just getting down to this, in 5.8 gigahertz mode, you can see 5.8 gigahertz SDR, 5 megahertz bandwidth. They've got 29.01 dBm, 800 milliwatts. So basically a watt capable of RF power back up to the drone. So the drones can do a watt down in FCC, this can do a watt up in FCC, and it's going to be interesting to see how that performs. But the good thing is they're both basically capable of matching each other. Next, moving over to the Antigravity grip, and the first thing to take from this is it looks like they're basically doing exactly the same as DJI do with the Goggles 3 and the Love Toy, and that is the remote communicates with the goggles communicate with the drone. The remote works on 2.4 gigahertz GFSK, which is basically Bluetooth. There is so little power output from this remote, it's crazy. It looks on the report to be like not even 100 milliwatts. If I just scroll down to the maximum conducted power was 9 dBm, which is 96 milliwatt, just under 100 milliwatts, basically, of RF power. It's that little. That is definitely not communicating with the drone at that. So what they're doing is the remote is talking to the goggles, which makes sense because if you look at the video, it's AR, the sticks are moving around. It makes complete sense that was the case, but it's nice to actually see it somewhat confirmed here in the FCC filings. Okay, so as you've seen, we've learned an awful lot about the Antigravity A1, and I don't even have it on the bench yet. However, I have to say, what I've seen, I'm really impressed with so far. This is the first time for a while I've seen something that I think is up there with DJI from a hardware perspective. Elements of it are not. Let's be clear. From an RF perspective, DJI are leagues ahead of anyone else. OcuSync is their own in-house system. There isn't anything that comes close. But this choice of Artisan is the only real other option on the market they could have chosen. And whilst it's not going to be quite 03 or even 04 performance, it is the best choice they could have made other than spending millions and trying to design their own system. And maybe they will do that in some time. DJI even worked with Artisan in the early days with Lightbridge. Artisan are a company who've been around quite some time. It's used in Avatar HD. It's not remotely surprising they're using it here. So whilst Antigravity may struggle on the live feed, that isn't to say the rest of the drone can't keep up. And honestly, the choice of components looks good. The build quality in the images looks decent. I haven't got it in hand yet. But the base platform, to me, feels like they could bring the fight to DJI. There is no reason, looking at this, they couldn't take off those 360 cameras and make a version of this to compete with the Mini 5 Pro. Get that into the US market. In less than 3 weeks, DJI won't be in the US market officially. Unless something changes, there is a huge opportunity here for Insta360 Antigravity. But remember, they are still a Chinese company. It's not a US company, so that could still be a problem. But my point I want to really make is this is the best alternative start I've seen. And if Insta360 and Antigravity can push forward from here, we could have a game on. And it's the first time I have felt like that's a possibility for a very, very long time. Now, if you'd like to see more when my drone finally comes, please hit that subscribe button. If you'd like to support the channel to allow me to keep making content like this, please do consider checking out the link to my Patreon as well as buy me a coffee. It is only through the support of my patrons I'm able to keep making content on this channel. And if you'd like to support us, please do consider checking it out. I want to say a massive thank you to every single one of my patrons. We'd not be able to do this without your support. Anyway, that's it for me in this one. Stay safe. I will speak to you soon.